time I forgot to occur, right? Which is too bad because it's a very important lecture about projectile motion. So I think we stopped here, okay? And so it's a projectile motion, but with a horizontal velocity. So example, okay. Here I have the simulation here. You see here, you're gonna launch a projectile. The velocity here is only horizontal. So for the test, it will be only in that case here. Okay, we're not going to do the one where you have to launch at an angle. So you see here the initial velocity, you see it's a vector. The magnitude is 50, unit is meter per second, and it's just horizontal. Do you agree? Now what's going to happen? Along the x-axis, the velocity will stay the same, right? So along the x-axis, it's moving at a constant velocity, but along the y-axis, it's going to be in free fall. So it's doing two things at the same time. So you're going to have two sets of equations, right? So let's see. I'm launched. Ready for that? Okay, launch. No. Do you see what's happening? Let's go back. Do you have an initial vertical velocity here? Do you see any vertical velocity to begin with? No, okay? You are not mad at a projectile. You don't throw it. You don't give it a momentum down. So the initial velocity is only along the x-axis. Copy me? Okay, so you fire up. Do you see what's happening to the y component of the velocity? It's increasing, right? It's increasing at a rate of -10. Every second, it's getting 10 meters per second faster. But along the x, the velocity stays the same. Okay, so if I do that again, you see the y component, the velocity along the y is increasing, so it's just in free fall, like we have been doing. Along the x, it's moving at a constant velocity, so it's cruising along. So the equation is very easy. It's just delta x equals v times t. For the y motion here, you have to use those equations, right, with the t squared. See? Now what is interesting to see here is that along the x-axis in the forward motion, it's a constant velocity, so it's called a uniform motion. There is no acceleration because every second, it's going to cover the same distance. But along the y-axis, it's going to be in free fall. So every second, you see it's going to fall farther and farther away. And the two things are happening at the same time, and they're going to ignore each other. So at any time, I'm going to have an x component, how fast it's moving forward for the velocity, and I'm going to have a y component, how fast it's moving downward. So that will take us to talk about vectors a little bit, right? So here, that's a projectile, and then it's going to hit the ground. Okay, so in the y direction, it's accelerating at a constant rate. So it's called a uniformly accelerated motion. Along the x, it's just a uniform motion. Okay? So along the x, I'm going to use that kinematic equation. Along the y, I'm going to use this one. Okay? So this is an experiment you can even do at home. You can predict, like, let's say, so you launch like, so the ball here, so it's rolling. There is no friction. So it's moving at a constant velocity and it's going to be launched here, right? So the initial velocity is only horizontal and it's going to describe a parabola. That distance here, that's going to be your delta x. Delta x, the x displacement, is a vector. You connect the starting point to the last point, right? So that will be your delta x. How far did it go? Now from here to there, that will be your delta y, the y displacement. How much down it fell, right? And then you combine both. So let's say you want to do an experiment to get extra credit, you want to make a video, you can predict, how long, you can measure how long it's gonna take to fall, and maybe you are measuring the range. I mean, you can do all kinds of computations. Okay, and boom. So you can see here that at the t equals 0, the velocity is only horizontal, right? And then it describes a parabola. So you see that will be your y displacement, that will be your x displacement. So you are using two sets of equation. Just to make sure that it's clear. Any question on that? So I will get back to that when we're going to start talking about vectors. Okay. Don't ask me why there was a mattress. I don't know if you have mattress in the savannah, but you have an antelope. It's being chased by a lion or lioness, and it's up the hill. So the velocity is horizontal to begin with, and the question is find the delta x, right? The forward displacement. So don't stare, do it. And it's already kind of done for you, but I will redo it. So if you have any question, let me know. So first thing you want to do is xy coordinate system. Okay, so you take your origin somewhere. So I'm going to take it here. That will be your plus. And that will be your the plus, but y. Obviously, that's going to be minus here and minus there. So in that case, you see the displacement here. That will be minus 30. It's a vector. And that will be your vector displacement, but along the x. Okay? And then you use the methodology. So always the same methodology. You put your y here. What's happening along the y? It's just falling toward the earth. And only gravity is acting on it. Along the x, it's moving forward. Okay, but it's cruising. So what should I put here? I always put always negative 10. Let's look at the initial velocity. The antelope is not going to have a momentum down, right? So there is no initial velocity down. Do you agree? You have a velocity down if you push it down, right? So if someone, maybe the lion jump on it and now it's being pushed down, but here it's not the case. So initial velocity is 0, and we do have the displacement, okay? It has to go here because it's along the y. Do you agree? Okay. And initial velocity along the x, it's 60. It's like a projectile. It's like a cannonball, right? So I'm going to put here what I know. Initial velocity is 60. If you want, you can put a little x here, and to make sure you understand that's the initial velocity along the x, you can put a little y here. But, since you have y here and x, make sure you understand they are not the same. Okay, boom. And then what else? Okay. we have always the same equations. This one is cruising. So displacement equals initial times time. There is no acceleration along the forward motion because there is no force. No force, no acceleration. There is no draft. It doesn't have an engine or something like to push it forward. And here we always have the same equation. Gets boring. Delta y equals nya nya nya. So this is only for free fall. Don't do the mistake that for the test, if you have a motion along the x-axis, you're going to put a 5 here. No, here it should be half of the acceleration. Okay, so the equation is delta, for example, delta x equals v0t plus 0.5 a t squared. Okay, or you can have delta y equals v0t plus 0.5 a t squared. But it just happened that if a equals negative 10, so half of it is going to be negative 5. But this is only true for free fall. If something is slowing down or spinning up on the highway, so it doesn't go up or down, so I cannot use this equation here. I have to use this one. It will depend on the acceleration, right? How fast you're getting faster or how fast you're getting slower. Is that clear? Because I see that mistakes very often. So understand what you are doing. You have to see through the equations. Otherwise, you do the mistake to rush and to plug, hoping for the best. So sometimes prayers are on the listen to, but sometimes they are not. So don't do that, okay? So final equals initial minus 10t only for free fall. V square equals V0 square minus 20 delta y only for free fall again. Okay, otherwise you have to use the equation v square equals v0 square plus 2 times, for example, delta x times the acceleration, right? And you have the equation v equals initial plus at. So you use this here, minus 5, here you have a minus 10, minus 20, only in free fall because the acceleration is minus 10. You get that? Okay, so once you have done that, you can breathe. So we want delta x, but we do have initial velocity, but we do not have the time. So how can I find the time for the fall?
v0 times delta minus 5.
Very good. I get it from the y, right? For this first equation. Do you agree? Okay, so delta y, I know it's minus 30. Initial velocity is 0. Okay, so that term is 0 because the antelope is not pushed down when you start your stopwatch. And it's going to be minus 5t squared. Okay? So minus and minus is plus. So t squared equals 6. So t equals square root of 6. So t equals 2.45. Okay? Do you agree? And then the time, I lost my little thing. I lost my eraser. Here. The time is like little mouse. Chung chung. And then it goes here. So the time goes on both sides. So time is 2.45 seconds. So now I can find delta x. Yes? Okay. So delta x equals initial velocity is 60 times 2.45. So delta x equals
147.
147. 147?
Yeah.
Meters? Do you all agree?
Yeah.
So this is 147 here. And before the antelope is gonna hit the ground, before hit the mattress, because we don't want the antelope to be injured in that experiment. You see, it has a horizontal velocity that always stay the same, but now it has a vertical velocity, right? V sub y. Do you agree? So velocity for the y, here you don't have any, and then it's going to increase, and then it's going to increase, and then it's going to increase even more. The x component's always the same. That's how it works. Agree? Mm-hmm. Okay, so can you find, and at the same time we are reviewing, because it's kind of kinematic, we are reviewing for kinematics1d, because kinematics2d has two components of kinematics1d. So can you find the y component of the velocity just before the antelope is going to hit the mattress? I hope it's a good mattress that the antelope bought at Costco. So, what did you say? Yeah, 24.5 meter per second. Do you all agree? Okay, so you use this equation here. So V0 minus 10t, right? So the final velocity along the y, this is 0, equals minus 10 times 2.45, which is minus 24.5 meter per second. Do you agree? Mm-hmm. So it means that yeah. So you see when it's just before it hits the ground, it has a x component. The x component is 60 meter per second, and now the y component is 24.5. So what's the meaning of that? And that's going to be an introduction to what's coming next. It means it's doing two things at the same time. It's moving forward with 60 meter per second, but it's also going down with 24.5, right? Mm-hmm. So if this was ice and not a mattress, maybe it's a very icy day in the savannah. So maybe it's all ice here. So the antelope is going to do two things. She's going to keep moving forward, right, with the same speed, but at the same time, it's going to hit the floor with that speed. And that's the killer, right? It's not the fall that kills, it's the impact. So why is that going to be very important? So let me introduce, and then we'll go back to that. Let me just introduce vectors, right? So vectors, it's like arrow, right? So they have a tail and a head, and you don't want the vector to fly away. So let's say here you take the origin here, so it has 60. We call that the x component, and 24.5, we call that the y component. So you make your point here. So that point here is going to be 60, 24.5. I didn't do anything special, right? But then, because it's a vector, it needs a tail and it needs a head. So the tail always here at the origin, and that will be the head. This is what we call a vector. It has a magnitude, how fast, a unit, meter per second, and a direction, right? And we'll talk about the direction later. The unit is meter per second. So far we talked about the X component, how fast it's going forward. We talked about the Y component, how fast it's going down. But this is just a mathematical trick. In the real world, you want the speed. Okay, in the real world, you don't talk about velocity, you talk about speed. And any idea how we can find the speed here? You see? Yes, Pythagorean theorem. Do you all agree? You have a right angle triangle, right? So a square plus b square equals c square. So that's how you can find the magnitude of a vector, is by using Pythagorean theorem. Okay, so just an introduction. I will talk about vector. And of course, I cannot do all the work for you. You have to read your textbook. And in the textbook, they talk about vectors, right? And trig. So you want to review that. And you can also find the direction here. So it's a right angle triangle. And what can we use to find the angle in a triangle? The sine or the cosine or the tangent, right? So in that case, tan alpha equals, so you are sitting here, opposite 24.5 over 60. So you can find this angle here. That's why I told you to review trig. So I hope you did. But I will get back to that. So just an introduction. So how can you find that angle here? Use tan. Okay. So that will be opposite over adjacent. Okay, and I hope you did review trig. So then you do arctangent here. Opposite is 24.5. Adjacent is 60. So that angle will be 22 degrees. Okay, so what does it mean? It gives you the speed and the orientation, right? It does matter. Because if the speed is just along the x, it's not going to hurt the antelope. But if it's really toward the y, it's going to hurt bad, right? So you need the orientation. So that's going to be 22 degrees. Okay, and you can use Pythagorean theorem to find the magnitude. So I'll get back to this, but that's the idea. So again, if I go back to this app here, so at all time, or at a given time, the projectile has two components. One is the x component, how fast is going forward, and one is the y component, how fast is going downward. But that's to solve your problem. At the end, you want to combine the components. You use Pythagorean theorem to find the speed, and you use a tangent to find, which way it's pointing. Is the velocity this way? Is it that way? Is it that way? Is it that way? Agree? So you see, as the time passes by, the y component is increasing, the x component stays the same. If you want to find the speed, you will use Pythagorean theorem. And if you want to find the orientation, the direction, you use tangent. Okay? I don't know if I have another one. So I'm going to show you the velocity and its components. Let's see, fires, boom, almost. You see, this is the x component, this is the y component, this is the origin, and that will be your velocity. So again, to find the speed, you use Pythagorean theorem. To find this angle here, you have to use tangent. And then, boom, yay! 3 stars. Let's look at acceleration. If I do the acceleration, always, acceleration is always down, 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 always down. Okay, so let's do this one, and then we can move to vectors. So the story is the tennis ball just clears out the net. The net is 1 meter high, and the tennis court here, that tennis court here, that side of the tennis court is 10 meters. So the net is 1 meter high. The tennis court is 10 meters. Question is, find that velocity here, right? So it's like a projectile that is launched. It's a horizontal velocity. Okay, that's all you will have. Find that velocity. So staring doesn't help. What you want to do is follow the methodology. So you make your two sides here, y and x. You have all your equation and fill out whatever is given to you. So d is 10. The height here is 1 meter. And you need to find the horizontal velocity. And do not stare. Do. So if you have a tablet, it's very nice. If you have a notebook and an eraser, that's cool too. So you always want to put let's choose an origin. So let's say this is my origin here. So that will be positive y, positive x. Always you need to decide of an origin. So what else is given? You know that down. So that will be your displacement here. That's going to be 1 meters. Okay, it's given. That's the height of your net. And the x displacement is 10 meters. That's how you translate the information that is given to you. And you want to find the initial horizontal velocity. Okay, so do it. So don't wait for me. So you follow exactly the same thing. It's kind of boring here. Boom. And then you have another thing here. And maybe another thing here. And yeah. You see, it's always the same. So acceleration here is always minus 10. Initial velocity, the tennis ball has no vertical velocity. Okay, it's not being pushed down. It's just going horizontal. So it means here it's going to be 0. That will be the height. Height has to be here. That's the vertical motion. That's horizontal. Okay, so delta y equals minus 1. Okay. Let's see what is given here. We always have delta x equals initial velocity, which I'm looking for, time. And I know that delta x equals 10. If I should be exact, I should not do it this way. I should be more careful and keep the next column for the equation, right? So the equation here, that's what this is called the initial condition here. T equals, not T equals 0, but what is given, what you know, this is given. And here you have the equation. So delta x equals only in projectile motion. There is no acceleration. And you have all those boring equations. Delta y equals nya nya nya, nya 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 nya, nya 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 nya. No, 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 no. Okay? Okay, so once you are done with this, that's it, right? Then it's easy. So what can I do? So you want to find the initial velocity. Look at the equation. Delta x you have. Do you have the time?
No.
No. So the only way you have is to go to the other side and ask for the time. I want the time. Say, okay, no problem. I have 1, 2, 3. I should be able to solve it, right? So which equation do you want to use?
First one.
First one. So minus y minus 1 equals, this is 0, minus 5t squared. And you can solve for the time. Take the square root. And you get it should be 0 point something, right? 45 second. And then again, you make a little tunnel. Pium, 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 pium. Ça y est, equals 0.45. And now you can solve for v sub 0. Agree?
Mm-hmm.
So delta x is 10. Initial velocity, I don't know. The time is 0.45. So initial will be 10 divided by 0.45.
22.
22?
2022.
2022?
Yeah.
20. Oh, 22.22. Okay. That's good enough. 22. Okay? That will be your initial velocity. So what's going to happen next? It's going to describe what kind of curve? Parabola, right? And it's going to hit the ground here. And just before it's going to hit the ground, the velocity will still be 22. But the y will be 4.5. So it's less, right? It's going to be 4.5. Okay, so it's moving forward with 22 and it wants to hit the ground, okay, down with a velocity of 4.5. Why 4.5? Because final velocity equals initial minus 10 times t. Okay? Is that clear?
Mm-hmm.
So kinematics2d, if the algebra is not too heavy, it's just two problems of kinematics 1D. Okay? I had like where are those equations? So before we move on to vectors, again, because I over the years I see always the same mistakes. So I want to make sure. This I did last time. But again, these equations here, so this is the uniformly accelerated motion. So this is when you have something moving along what? X-axis. Very good. So only along the x-axis, right? And you're gonna have so along the x-axis, right? It's so annoying. X-axis here. So at a given time, you have the position on the number line. The x sub 0, it's when you start, you stop, watch. So in that case, you have an acceleration. Acceleration can be positive or negative. If it's negative, it doesn't mean that it's slowing down. Negative means there is a force to the left. So if you are moving to the left and there is a force to the left, then you are accelerating. If you are moving to the right and the force is to the left, then you are slowing down. Remember that? Mm-hmm. So this is going along the x-axis, right? Horizontal motion. Mm-hmm. And then for free fall, so free fall could be you drop something, you get mad at your professor, or you toss something. So in those cases, only you have, in that case, you're going to have acceleration is -10, and the equation will become final equals initial minus 10t, and then you have a delta y equals initial minus 5t squared, and then you have final square equals initial square minus 20 delta y, and why not average equals delta y over time, which is also initial plus final divided by 2. Only for free fall. And then if there is no acceleration, so that means if the velocity is constant, but you are again moving along the x-axis here, it's not very convenient. So you are moving along the x-axis here, but the velocity is constant. Okay, so acceleration is 0. So in that case, you have delta x equals v0t. So constant velocity along the x. Free fall, acceleration is -10, but that will be along the y. Okay, that's plus, and that's minus. And then acceleration, but along the x. Any question? And do remember that displacement in 1D is just the final position minus the initial position. And initial position is the location when t equals 0. So it's a review. We talked a lot about that. Is that clear? So for projectile motion, you are using only those two sets of equations. For any other types of motion, so if it's free fall, you are using this. If it's uniformly accelerated, you are using that. And if it's moving at a constant velocity, you are using this. Okay? So it's just a review. Just a parenthesis here in his book, Newton. So it's the most famous book in physics, obviously, because Newton is the father of physics. It was called natural science at the time. It was not called physics, but the book is called Principia. And then in that book, you see, he was drawing a earth here and a very high mountain. And he understood that if you fire a projectile, and if the projectile hits the ground, you're gonna get what type of curve? Parabola. It has to be a parabola. Now, if you fire with enough speed, okay, the Earth is curving away, so you will never reach the Earth. So in that case, it's going to be a circular orbit. The guy was a genius, okay? Huh?
For satellite.
Satellites, exactly. He was understanding satellites before the space age, right? It's like a satellite, exactly. And he imagined that if the velocity will be even larger, you will get into an ellipse. And even larger, you get the escape speed and you can escape the Earth. How smart, right? Except he didn't have color pencil, so it's in the book. It's all white, white and black and white. Okay, so do you want to do one more, or that's it? You understand? Huh? So this is in the Dropbox, by the way. Do you want to do just one? Let's just do one. That's it. Just one. And then we're gonna get to vectors. And you really need to understand trig, cosine, sine, tangent to understand vectors. And you need to read your textbook. Okay, so you always make a table, a drawing. That's a table. A bullet. No, yep, it's a rifle. I don't know why I make a table. It's a rifle. So that's your projectile. And it has an initial velocity here of 200 meters per second. This is a nonsense problem because, I don't know, it seems very, very far, 2 kilometers. But I don't know. Forget about the nonsense, right? Just focus on the physics. That's your target. It cannot be. That's fine. Okay, so here you have your delta x. You have your delta x, okay? That's your target. And here you have your delta y. I don't know, my drawing is not very good. I'm not very happy. But do it, okay? Don't wait for me. I don't know, it's a target on oh yeah, I know. It's like suspended. It's a suspended target. Okay, that's better. So delta y and delta x. So don't wait for me, okay? So just apply the same methodology. Y-axis, x-axis. So acceleration is minus 10. Initial velocity is 0 because the gun, it's a powder here. It's going to push along the horizontal. It's not going to push it down. And what else do we know? Oh, delta x here equals 2500 That velocity here, where does it go? X or Y? X, okay? It's the initial velocity along the X. Okay? Next comes the equation. So equation is always the same. And then you have the delta Y equals nya 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 na nya 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 nya. Okay. Okay, so which equation I can use to find the time? X, very good, the X. Here, you see, 1, 2. I don't have enough, right? So I'm gonna have to use the X. So it's gonna be 2500 equals 200 times the time. So boom, 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 boom. Time equals
12.5.
exactly. Do you all agree?
Mm-hmm.
It's a problem that does not make sense. It's okay. It's I mean in the real life. And then you see here it's gonna sneak, and now we have t equals 12.5. How far the bullet fall? How far did it fall? So you need to find the
Delta Y.
delta y. Very good, right? The y displacement, right? Fall is down. So I need to find. So I'm going to use this one, right? Mm-hmm. So I have delta y equals initial velocity is 0. So it's going to be minus 5, 12.5. Is that right?
Isn't it squared?
Oh yeah, you're right. See, I wanted to do it in my head, but no, it's not going to work.
Negative
It's
781.25.
negative
700.25.
81. Okay, so 781 meters. Do you agree?
Yeah.
Absolutely no, no sense, but it's okay. The physics is good. Okay. Oh, okay. So now we want to find, so the velocity is here. So the velocity of the bullet here, final velocity, it has two components. So what's going to be the x component? It stays the same. So along the x, what's the x component? The x component always stays the same. It does not change because it's cruising along. So at t equals 0, it was 200. Mm-hmm. So at all time, it's going to be 200. What about the y component? So can you find the y component?
Yes.
So how do I do that? The y component, that's here, v in the y, that will be the y component. So vy equals minus 10 times 12.5. Do you agree? Right, so that will be the y component. If you do your homework, if you don't constantly asking me to extend the homework, you know what I'm talking about. Otherwise, if you don't do your homework and you don't study, you're going to be lost. Little by little, you're going to be more lost and lost and lost. So make sure you keep track, right? Don't fall behind. So 125. Well, that will be the y component. So along the y, the velocity is going to increase. Along the x, it's going to stay the same. So the velocity has two components. But now I want the magnitude. How do we find the magnitude? Pythagorean theorem, right? So let's do that together with the TI in one shot. One shot. Ready? First, you take the square root. Okay? Second square. So let's square root. There is no minus. Okay? You don't want minus, right? So it's square plus. So here's another mistake that I see. Because here the y component is negative, you want to put a minus. No. Because square, remove the minus, right? Minus and minus is plus. So 125 square. So using Pythagorean theorem, the speed is about 236 meters per second. Are you with me? Pythagorean theorem. Very basic math. Okay? Do you agree? Okay. So that will be the speed in real life. If you are doing like forensic, for example, you want to know, the speed of the bullet, so the gun that was used, things like that. So you need to find the speed. Okay, so that will be the speed here. And then you can find that angle here. Can you find that angle here? Okay, so a little bit of geometry. You see, you have I don't know where to do it. I'm going to remove the bound. So you have a right angle triangle. So this is supposed to be right angle. This is 200. This is 125. That will be your hypotenuse, about 236, and you want to find that angle here. So basic geometry. Do you agree? Anyone? Yes.
1.5.
Here. So the y component will be the time times 10. Initial velocity is 0. So it will be 10 times 12.5. So it's 125. Do you agree? So that angle here, you use, let's do it together. You go second tangent. Okay? So you see in an angle, in a triangle, let's say you are here, this is you, and you look, this is opposite. This is your opposite side. And next to you, this is called the adjacent. Opposite over adjacent. So it will be tan, so arc tangent, 125 divided by 200. That's going to be 32 degrees. Okay? So that's going to be 32 degrees below the positive x-axis. So for the test, you don't have to worry about it too much, but for after, you have to worry about it a lot. Because when we get to forces, you need to understand trig. You cannot survive without trig. You need to understand trig. You need to use tangent, cosine, and sine. You need to understand Pythagorean theorem because we're going to learn about vectors. You cannot skip through. You have to. Okay? So anyway, it's just an introduction. Do you agree? Okay. So if you want more problems, by the way, for test number 1, it's on next Thursday, in class, in person, multiple choices. You can print out the equation sheet. You can bring the equation sheet. You can bring a pencil or a pen. Pen is better. A calculator, scrap paper. Don't miss the test. Don't have a flat tire or a dog that is sick. I've seen that. I've seen a lot. Sick dogs and flat tires for some reason. And no, because otherwise, if you have a very good excuse, you can have a makeup, but I don't have enough time for you, right? So I will have to remove the amount of questions, right? So it will be harder. So make sure not to miss the test. And if you have the DRC thingy, you have to contact them and secure a spot for the same day and the same time. So on Canvas, you have a practice test online. It does not count. And if you go in my Dropbox, you have a tutorial for that, okay? Any question? Okay. So let's talk about vector. So remember, a vector has a tail and it has a head. So it has a magnitude, how much, a unit, and a direction. So usually, so if you don't have issue, if you go into physical therapy, a lot of people like me, when you get old, you have rotator cuff issues. So if you do not have rotator cuff issues, you should be able to do this, right? You should go. So this is the positive x-axis, right? And then that will be 90 degrees. You with me? 180. That's going to be what? 270. And that's going to be 360. So we always go counterclockwise. So when I had issues with my arm, I could not do this. So then you have two solutions, right? You go to a physical therapist or you take a shot. Physical therapist being better, but the shot going faster. So anyway, so this is the positive x-axis, right? And when you are finding the direction, you always start from the positive x-axis. And then you're going to show here that will be, for example, a vector, right? Maybe it will be a vector position. And you need to find this angle here. So from the positive x-axis, that's going to be the direction. That will be the magnitude. And we call that a vector. Agree? Okay. So why do we use that? We use that a lot in all kind of science. So for example, environmental science. So this is called a vector field. What kind of vector is this? So it has a direction, but which physical quantity? The velocity. Right? Physical quantity meaning displacement, velocity, force, acceleration, momentum, energy. Okay, so in that case, it's the velocity of the wind. So the wind has a direction, okay? It has a magnitude, okay? What's the speed? And a direction, a unit. So the unit here is meter per second. So here you can use color also. So you use a code to show that here it's going to be very small. The magnitude will be very small, and here the magnitude will be very large. So the magnitude will be the length of the arrow, and it's going to show you how strong is the wind. So that will be a vector velocity. And again, you need to show the direction. Right? Okay? So for example, you have something called a vector position. So imagine here, I am at the origin. And you see the projector over there? So I can trace a vector attached to the origin and pointing at that projector here. So that will be a vector position. And again, it has a direction. So in that case, 30 degrees above the positive x-axis. It has a magnitude. So how far is it from me? And a unit. Are we talking inches? Are we talking meters? So in that case, it's in meters. Do you understand? Very important to understand because we're going to get to forces. And if you do exercise science, for example, everything muscles and everything, it's all about forces. And of course, you need to know your trick, right? So you have a link here. Khan Academy. You can review with that. Okay. So, okay, let's talk about components. And no, I'm going to take an example. So if you were a bird, you can fly straight from New York to Detroit, right? So what physical quantity is that? So it's not distance, it's called displacement, right? So you connect the starting point to the final point. So this is a vector displacement. But maybe you want to know how far did you go west and how far did you go north? Because maybe Ohio is fine, but maybe what is, do you know your state? What is next to Ohio? Illinois? Indiana? Okay, maybe you are at war with Indiana and you want to make sure not to cross the border, right? You want to make sure you don't get to Indiana. So you want to make sure to know how far did you go west and how far did you go north, right? So this is called the X component and this is called the Y component. Okay, so this displacement vector has two components, westward and northward. Okay, so you have two ways to describe this vector. So let me show you. So from here to there, I look at a map, it's about 600 miles, and this is about 10 degrees. Okay, and then it depends how good you are with geometry. So I will show you a way to do it where you can memorize. But okay, so this is 600 miles. And this is given here. I tried to measure it. I did that myself. 10 degrees. So this is north, this is south, this is west, and this is east. Do you agree? So you can say that the displacement AB, okay, has a magnitude of 600, so 600. How much of what? Miles. Which way? 10 degrees. 10 degrees, what of what? You go west, but it's north of west, right? Exactly, so northwest, right? So military people, they will use this notation, northwest, which means you start from north, you start from west, and you go north. So north of west. Off. Here means off. North of west, right? This is not the physics notation, but I will get back to this. But at least you have your vector. But now let's see. How far did you go west? So now we want to find what it's called the X component. I'm going to call that the Y component. So how far did you go west? If you have the right angle triangle, that will be called what? The adjacent or the opposite? Adjacent, right? So how do you know that? You take your right angle triangle, you have a little guy here. So this is my adjacent here next to me. This is the opposite, and this is the hypotenuse. So in that case, it's going to be 600 times, and then you do cosine. But here you have to be careful. It has to be west. West is like minus. Okay? So you do 600 cosine 10, which is 591. Do you agree? What does it mean? It means that you want 591 miles west. I should put like the unit here, right? 591 miles west. So westward. Okay, I'm good. I didn't cross the border with what? What did we say? Illinois? Indiana. Thank you. So the Y component is going to be what? So what do I use for the Y component? Sine. Now it's going to be north. So it's going to be 600 sine 10, which is about 104. Do you agree? North. Okay? Now, why do we have to be careful? Because if you use the physics notation, right is plus, left is minus, up is plus, down is minus. So that means that your vector AB, the x coordinate is going to be minus 591, and the y is going to be 104. Minus because it's pointing to the left. Plus because it's pointing up. So you have two ways to describe your trip. You can say, I went 600 miles, 10 degrees north of west. That will be fine. Or you can say, I went from New York, I went 591 west, and then I went 104 north. In both cases, you're going to end up in Detroit. Agree? Mm-hmm. So this notation is using what we call the Cartesian system with the x and the y. And this notation is using what we call the polar graph. Okay, so that means that I'm going to show you what a polar graph is, but at least you get the idea, right? So you do x, y axis, minus 591 is going to be here. So 591, 104. So you have your point here. When you have a vector, it has a x component and a y component, a x and a y. Like you do basic math, right? You always know how to find a point in the coordinate system. And then a vector has a tail and a head. So you attach the tail here at the origin so it doesn't fly away, and that will be your vector here. No, I know someone is raising the hand. No. What did I do as a mistake? Yeah, thank you. So 104 is up, right? 104. Yeah, because 10 degrees is here. So that will be your point here. Do you agree? Okay, and that's gonna be your vector. And that will be 10 degrees. That will be your vector here. Is that right? Yeah. So that's a good question. I'm gonna get to that. 591. So if you show it this way, you can see where is your vector, right? But if you want to write it down, okay, and you want to use the polar graph, you have two ways to do it. You can do the military way, so that will be 10 degrees north of west. But if you want to use what we call the standard notation, so then you take the positive x-axis, right? You go counterclockwise. So what's going to be that angle here? 170 degrees. Mm-hmm. So in physics, so this is the military people, but the physics people will say AB, okay, has a magnitude of 600 miles at, you start from the positive x-axis, no rotary cuff issues, you point here just 10 degrees above, that will be 170. So this is called the standard notation. Okay, or in the polar graph. I didn't lose anyone. Now, why do you want to use this notation? Because then you don't have to think, you memorize it. So if you use that notation, cosine will be always for x, sine will be only for y. If you use that notation, the x component will be always cosine and the y component will be always y. Let's see. 600. Okay, and then I do cosine 170. I get my negative 591 or 591 west. Okay? Do you agree? And then 600 sine 170. And then you get your 104. Okay, so I will show you again, but that's the idea. So if it helps you, so again, you see 600 miles, 10 degrees north of west. Okay, so this is the Cartesian coordinate system. So minus 591, 104. Okay, if you use a standard notation, that will be 600 miles at 170 degrees. Yes.
Okay. So in the exam, would you like tell us like the name of how you want us to do?
It's in the exam, you have multiple choices. So I will say, okay, you have a vector 600 miles, 10 degrees north of west. What's going to be the x component? What's going to be the y component? Right? Now, it depends if you know your sine or cosine. If you don't know your sine and the cosine, and you can print out that polar graph. So this is called the polar graph, right? So you have 0, 90, 180, 270, 360. Okay? So let me show you what it looks like. So usually you always go counterclockwise. So 0 degrees, do you agree? 30, 60, 90 could be north, right? Or 90 degrees. Then you increase 120, 150, 170, 60, 70, 180. Do you agree? So first quadrant, second quadrant, third quadrant, 270. And then you go to 360. Okay? If you have a vector and it says you are given 600 miles, 10 degrees north of west. So you take your polar graph that you can print out. You can take it for your assignment or test. So then you say, okay, 10 degrees above the horizontal is going to be here. Do you see that? And then you don't have to think because that's going to be your point here. So if you use polar graph, okay, you're going to say it's 600 miles at 170 degrees. So I know what I'm talking about. Or you can say this vector has two components. So this is the y-axis, this is the x-axis. The components of the vector will be your x and your y. That's it. You remember basic algebra? When you are given a y and an x, remember middle school? And you have a point here and you need to find the x and the y? Same thing. How can I find the x? Memorize. If you don't know your trick. So in that case, it will be 600 cosine, whatever you are reading here. To find the y, you do 600 sine, whatever you are reading here. But for that, you need a polar graph. So for example, if you are given 30 degrees east of north. So you say, okay, north is here, I go east. Anyway, you have only two directions to go. Go east, go west. So northeast, going this way, 10, 20, 30. Okay? So what is the angle that you reach here? 60. Let's say the magnitude here is, it's a velocity, 50. So you are launching, for example, you are launching a projectile at 60 degrees, and the velocity is 50 meters per second, right? So 50 meters per second. How can I find the x component? So I'm going to do 50 times cosine 60. Very good. How do I find the y component? Sine 60 times 50. Do you understand? What are we trying to find here? Just that point here. That point has a x and has a y. Do you see that? Why do we want to do that? Because in a projectile, for example, you can throw a projectile this way, like football, right? When you are playing football, you have a launch velocity. I mean, you have an angle, right? So that angle could be 60. So if the angle is 60, you want to know how fast the football is going forward and how fast is going upward to begin with. So a velocity is a vector. It has two components, forward, upward. So that's how it works. You can print it out if you want, so you can make your own. You see, I had this has 20 years. It's 20 years old. Yes, it's a relic. Yes.
Straight 30 degrees north of east.
So 30 degrees. Actually, you're right. It's east of north, right?
But you said 40 degrees, right?
30 degrees east of north.
10 degrees north of west was 10 degrees upward, and then
No, so north. So when you say north of means where you start. So north of west, meaning you start off west and you go north, 10, 20, 30. So when in that case, it will be 30 degrees east of north. Oh, you don't have to worry too much about that, right? It's orientation. But that will be east of north. East of north. Off means where you start, right? You start north and you go east, right? So for example, if I go here, of south. So how many degrees do you have here? 30 degrees. Which way? East or south? And that will be how many degrees here? South of west. Okay? And then if you take orientation class with the military, you want to take the angle smaller than 45 degrees, right? So if this is here, you will say south of west. And if you do it this way, you say west of south. But that's don't worry about it. It's just if you're interested. Do you agree? Mm-hmm. So you can read your own, or you can print it out. So a small review. You see here, you have the polar graph. 0, you can print it out if you want. 90, 180, 270, 360. You always go counterclockwise. And that will be the angles in radians, right? So you have 0, pi over 2 is 90 degrees, pi is 180, 270 is 3 pi over 2, and then here you have 2 pi, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. Agreed? Right? That's math class. Okay, so you see here, okay, so that questions come from the textbook. The question is, find the components of the vectors. Example, you have the vector b. apparently it's a displacement vector because you have the unit. So it says 15 meters. Let's see, this way 30 degrees, right? So it will be west. This is east of north, right? Find the components. Either you are good at trig and you do it like this. You are not good at trig. You use your polar graph. You copy and paste your vector in that polar graph, and then you do it. So why don't you do it? You don't have to do it this way. If you are good at trig, you use a sine and a cosine. If not, you cut and paste in the polar graph. You see it says 30 degrees from the positive y-axis. So you cut and paste into here, and that's easy. So that's for the people who I don't know, forgot their trig or didn't read my announcement about reviewing CAD Academy. So you don't stare, you do it. Are you doing it? So B is a vector. Always attach the origin, the tail to the origin. So 15, how much of what? And here, let's say if I do west and north, so this is north and east. So that will be 30 degrees east of north, so northeast. But that's not the right notation, right? So in the standard notation, you will say what? 60, very good. Do you all see that? That will be the right notation. Now, if you do it this way, then to find the x component and the y component is very easy. Okay, don't stare. Staring is not good. So it has two coordinates. Okay, so you take your TI. Cosine 50 is half. $13. Okay? So how do you trace that? You always start from the tail. So this is the tail, always attached to the origin, and this is the head. You go from the tail to the head. You're gonna go sideways and then up and down, or up and down and sideways. So first I'm gonna sideways. Okay? That will be my x component. And then I can go up. That will be my y component. Agree? Mm-hmm. Or I can go up. That will be my y component. And then I can go this way. That will be my x component. 7.513. That will be the point here. And it makes a rectangle there. This is 30, so that will be 60. So it depends how good you are in seeing things. If you see things, you can do it in your head. Okay, so this is 30, so that has to be 60. Depends on people. Okay? What about A? A is easy. So A, the magnitude is 8 meters. And down, what's that angle down? 270, right? And you see, it has no x component. You see that it has no x component? Okay, if you do 8 cosine 270, it's going to be 0 because it doesn't go right or it doesn't go left. It's just going down. Do you agree? Mm-hmm. So if you do the cosine 270 is going to be 0 times 8 is 0. And that's going to be minus 8 meters. Okay? Is that clear? Mm-hmm. So make sure you go over your textbook. Let's try to do C. Try C on your own. Now you don't need the polar graph, right? You can do it in your head. You can say, okay, this is 180, that's 25. But if you don't remember, you forgot everything about math, then you can use your polar graph here. 170, 180, 190, 20, 190, 200, and that's going to be what? C will be 12 meters at, what's that? 180, 205. Very good, 205. Do you agree? 205. You can just do 180 plus 25, or you can use your polar graph. So in that case, the vector has two components. All you have to do, you take your TI, it's going to be 12 cosine 205 minus 11. And what? Negative 5 meters. Okay? So 12 sine 205. Okay? So this is the polar notation. This is the Cartesian notation. That means that point here, this point here is minus 11 minus 5. And what does it mean? It means that from the tail you go to the head. So that will be your x component. And that's going to be your y component. Or this is your y component, and that's going to be your x component. So this is 11 here to the left and 5 down. 5 down, 11 to the left. Do you agree? G is 53. So that will be west of north, right? So 53, you see you go 10, 20, 30, 40, 50. So it will be 143. Do you all agree with that? Mm-hmm. And you can print out your polar graph, and then it's easy. Okay? So G, the magnitude is 10 at 143 degrees. So you can find the x component and the y component. Now, if you are good at trig, all you have to do is sine 53 times 10, but you have to put a minus, or cosine 53 times 10, and you put a plus. That's for people who are good at trig. This, I'm helping people who are rolling their eyes. That's a different way to do it. Okay? So the x component, let's do it quickly, will be 10 cosine 143. It's negative because it's pointing to the left, so negative 8. And the other one is 10 sine 143. And it's 6. 6? Is it 6? Yeah. Okay, 6. Okay.